Welcome to our lesson on understanding rational numbers. So we're going to start with a little bit of vocabulary. The first is, what is a rational number? So a rational number can come in lots of different forms. They could be decimals, they could be fractions, they can be whole numbers. But the rule is, in order to be a rational number, it has to be a number that can be written as a fraction. So even if it happens to be in a decimal form, if it's a rational number, that decimal can be changed into a fraction in order to show that it is a rational number. And rational numbers basically fall into two categories. We have terminating decimals, meaning a decimal that ends. So it stops, it doesn't continue on and on forever, and it stops in zeros. Okay? So it's a number that if we were to divide it out and do a dividing problem, we would eventually get to the point where we would get 0 at the end and that decimal would stop. It's not going to continue on and on. It might be 1 digit, it might be 2, could be 5 digits, but it's going to stop after a certain number of digits. The other type of rational number is a repeating decimal, and it's exactly what the name says. The decimal, or part of it, repeats forever. So like in this example here, we have 0.3333333. That 3 is just going to keep going on and on and on forever. So when we know that is repeating, we put a little bar over the top to show that that part is repeating. Okay? Sometimes there's part of the decimal that isn't repeating, and then the very end of it starts to repeat. Sometimes it's one number, sometimes it's more than one number. But a repeating decimal is one that the end of the decimal just keeps repeating over and over and over again. Okay? So here's a couple of examples here for us. So we have A, B, and C, and we want to know which ones are rational numbers. So for the first one, it ends after 3 decimal places. So it terminates, it stops. That makes it a rational number. So it doesn't matter if there's a whole number in front or not. We're only looking at the decimal part of the number, but we're just looking at, does that decimal stop? If it is, that's a terminating decimal, which means it's a rational number. In the next one, you'll notice we've got a lot of decimal, but then at the end, they put that little bar notation on the top to say that 81 is going to keep repeating. So what that means is we're going to get 1.5399818181. That 81 is going to keep repeating over and over and over again. So we put that little bar over the part of the number that repeats to show us that's going to keep going on and on forever, which makes it a rational number because it is a repeating decimal. The last one, you'll notice that we've got lots and lots of decimals. It doesn't appear like it's going to end anytime soon, but I'm also not finding any pattern in there. There's no repeated number over and over and over again. It seems to be different numbers in different orders. That means it is not a rational number. We call those irrational numbers. So an irrational number is a decimal that doesn't stop or repeat, which means we can't turn it into a fraction. All right, so the bigger part of this lesson is going to be, how do we turn these fractions into decimals so we can see whether they terminate or repeat? So to write a fraction in decimal form, we're going to divide the numerator by the denominator. Okay? And then the decimal form of it will eventually either terminate, stop, or repeat. And then we'll use that bar notation. So when we set up our division problem, the numerator goes on the inside. So the first number goes on the inside. The denominator is what's going to go on the outside. Okay? So numerator inside, denominator outside. Neato. Numerator inside, denominator outside. It's just a little handy reminder on how to set these problems up. All right, on the back of the page, let's go ahead and actually divide some of these out. So you may be a little rusty with your long division, but that's why we're going to go through a couple of them together. So when we set up our division problem, the numerator goes on the inside, the denominator goes on the outside. And then we divide. So we ask, how many times does 8 go into 3? Well, it goes in 0 times, but I want to be able to keep dividing. So remember from last year, in order to keep dividing, we can add a decimal at the end of the number, and then we can kick in some zeros. Remember, we can add as many zeros to the end of a decimal as we want, as long as it's after the decimal point. So now I ask, how many times does 8 go into 30? Well, it goes in 3 times. And I bring that decimal up. 3 times 8 is 24. Subtract. 30 minus 24 is 6. And then I bring down my next number. And then I just keep making my way through the problem a step at a time. 8 goes into 60 7 times, so I put that number up top. 7 times 8 is 56. I subtract, you can do your borrowing if you need to, and I get a 4, and I bring down my next number. Now I repeat it. 8 goes into 40 5 times. 5 times 8 is 40, so I subtract that away. In this case, I get 0. There's no more numbers that I have to bring down, so I'm done. 3/8 is the same thing as 0.375. So that is a terminating decimal because it stops after 3 decimal places. Next, we have 7/18. So I'm going to put my 7 on the inside, my 18 on the outside. Since I know I'm dividing and I'm going to get a decimal, I like to just go ahead and put my decimal point in right away and add in a couple zeros. I can always add some more later if I need to, or if I don't need to use them all. So 18 goes into 7 0 times. So now I do 18 into 70. Again, you might not know your 18s all that well, so you just do a little scratch work off to the side or use a multiplication table. So let's take a stab at it. Let's do 18 times 3. See how close that gets us. So 8 times 3 is 24. 3 times 1 is 3, plus 2 is 5. That gives me 54. 18 times 4, that's 32. That gives me 72. So that's a little too big. So I'm going to go with 54. So it goes in 3 times. 3 times 18 is 54. And I subtract. I can do my borrowing there. And I get 16. And I bring down a 0 so I can keep dividing. Oh, sorry, I brought down that 0 there. So now how many times does 18 go into 160? Well, times 10 would be 180, so I'm going to be in the ballpark there. So let's try 18 times 8. 8 times 8 is 64. That gives me 144. So I think that's as close as I'm going to get. And that's 144. I subtract, and I get 16, bring down another 0. So how many times does 18 go into 160? Well, I just did that right here, and it goes in 8 times. So 18 times 8 is 144. I subtract, I get 16 again. If I were to keep bringing down another 0, I would keep getting that 160, and then I'd subtract away 144, and I get 16 left over, and it keeps going on and on. So that tells me that that part is going to repeat. I'm just going to keep getting that 8 over and over and over again. So I put that bar above the 8 to show that it's going to keep repeating. As soon as you pick up on that pattern, it's okay to go ahead and stop. All right, last 2. You can try these for yourself, or you can follow along and tackle them with me. Remember, the numerator goes on the inside, denominator on the outside, and then I like to just go ahead and add my zeros and my decimal. 4 goes into 3 0 times. 4 goes into 30 7 times, which is 28. Subtract, I get a 2, and I bring down my 0. 4 goes into 25 times, which is 20. I get 0 left over, and all I have up here are zeros. I don't have to bring down the zeros. They're just there if I need to keep dividing. So I get 0.75. It's a terminating decimal. Last one, 1/6. So I'm going to put my 1 on the inside, my 6 on the outside, and I'm going to add my decimals. 6 goes into 1 0 times. 6 goes into 10 1 time, which is 6. Subtract, I get a 4, and I bring down my 0. 6 goes into 40 6 times, which is 36. Subtract, I get a 4, bring down a 0. 6 goes into 40 6 times, which is 36. Subtract, I get a 4, bring down another 0. You kind of notice the pattern. I'm just going to keep repeating that. 40 minus 36 is 4, becomes a 40 minus. So as soon as you notice that, you know it's repeating. So you go ahead and just put that bar over the repeating part, and you're done. So that's how we check to see if it is a terminating or repeating decimal.